Welcome back to Science to Sleep By. Tonight, we're going to take a journey far beyond our daily lives. We'll start in our own backyard, the Milky Way galaxy, and slowly expand our perspective outward, until we reach the edges of the observable universe. This isn't just about facts and numbers. It's about scale, wonder, and finding peace in the vastness of the cosmos. So settle in, get comfortable, and let the stars carry you into a calm and quiet state of mind. When we talk about the size of the universe compared to our galaxy, it's almost impossible for the human mind to fully comprehend the numbers involved. Our brains are wired to understand distances like miles, yards, and feet. We can picture the size of a city, or maybe even an entire country. But when we start talking about thousands of light years, millions of light years, or billions of galaxies, the scale quickly moves far beyond what our everyday senses can grasp. That's where perspective comes in. Perspective helps us take these incomprehensible numbers and translate them into something we can begin to imagine, even if only faintly. It's not about memorizing exact figures, but about feeling the immensity of what lies beyond. Tonight, we'll use perspective to bridge that gap between human experience and cosmic scale. Think about it this way: if you were standing on a beach, holding a single grain of sand in your fingers, that tiny speck would seem insignificant compared to the stretch of coastline around you. But now imagine that every grain of sand on every beach in the world represented a star. The numbers become overwhelming. The Milky Way galaxy alone has hundreds of billions of stars, and each one could be represented by a grain of sand. If you poured all those grains into your hand, you'd see a pile that feels heavy and endless. And yet, our galaxy is only one of potentially 2 trillion galaxies scattered across the observable universe. That's perspective. It's the kind of realization that leaves you in quiet awe, feeling both small and strangely connected to something vast. Our first step is understanding why humans naturally struggle with these scales. We evolved in environments where distances rarely exceeded a few dozen miles. Our ancestors navigated forests, plains, and rivers. They didn't need to think about light years, which are distances so immense that light itself, traveling at 186,000 miles per second, takes thousands or millions of years to cross them. When you sit under a night sky, what you see is light that has traveled across space for years, centuries, or even millennia to reach your eyes. You're not just looking at stars. You're looking back in time. That's part of the perspective. Distance and time are intertwined, and the larger the scale, the deeper into history you're peering. This is why it's useful to start small and slowly expand. First, we recognize our own place on Earth, a planet that feels enormous when we try to cross it on foot, but which is just a tiny dot when seen from space. From the Moon, Earth looks like a marble floating in blackness. From Mars, it becomes a pale blue dot. And from the edges of our solar system, Earth shrinks into something almost invisible. What was once our entire world becomes less than a pinpoint, yet it still contains everything we know, everyone we love, every story we've ever told. This shrinking perspective prepares us for the leap to galactic scales, where our entire solar system is just a faint trace in one arm of the Milky Way. But even the galaxy is hard to imagine. If we could somehow shrink the Milky Way down to the size of North America, our entire solar system would be no larger than a quarter sitting somewhere in the middle of the continent. That's the kind of perspective that helps us begin to wrap our minds around these scales. It doesn't make the numbers smaller, but it gives us something familiar to hold on to, something we can picture in our minds before we drift deeper into the cosmos. What makes these comparisons even more powerful is how they connect us emotionally. Knowing that Earth is tiny compared to the galaxy could make us feel insignificant, but it can also be a source of peace. The problems we face in daily life, the stresses and anxieties that weigh heavily on us, seem to shrink when set against the backdrop of a galaxy filled with billions of stars. When we expand our perspective even further, to the size of the universe itself, those problems feel like ripples on a pond, temporary and fleeting. And yet, instead of erasing our meaning, the universe enhances it. To exist at all, in such a vast and ancient cosmos, is a miracle. To be conscious of it, to be able to reflect on it, is something extraordinary. Perspective doesn't just show us size, it shows us value. Another way to frame perspective is through time. The universe is not only vast in space, but also in age. It has existed for about 13.8 billion years. The Milky Way galaxy formed around 13.6 billion years ago, only a short time after the universe began. Our solar system, by comparison, is relatively young, at about 4.5 billion years old. Humanity, with its recorded history of just a few thousand years, is like the blink of an eye on this cosmic timeline. When we look at the stars, we're peering across both vast distances and vast ages. Some of the light reaching us tonight left its star before humans even existed, before Earth had continents as we know them, before the solar system had taken its present form. The perspective of time adds to the perspective of space, giving us a double lens to view the enormity of everything beyond. This is why astronomers often use analogies. They compare the size of galaxies to grains of sand, or the history of the universe to a single calendar year, where the Big Bang happens in January and humans appear in the final seconds of December 31st. These analogies aren't perfect, but they give us something to grasp, something that grounds us when the numbers become too abstract. If the entire history of the universe were a single year, our lives would be shorter than the blink of an eye at midnight. Yet, in that blink, we have the ability to wonder, to explore, and to seek understanding. That's the power of perspective. Perspective also connects science with philosophy. Scientists measure distances and map galaxies, but it's perspective that translates those discoveries into human meaning. Knowing that the Milky Way is about 100,000 light-years across is a scientific fact. Understanding that this makes our entire solar system nearly invisible in comparison is perspective. It helps us interpret what the numbers mean for our sense of place. When you lie under the stars and feel a sense of wonder, that's perspective at work. It's your mind translating raw data into AW. As we move forward in this journey, perspective will remain our guide. Without it, the scale of the universe is too overwhelming to make sense of. But with it, we can take the incomprehensible and shape it into something that feels approachable. We can imagine grains of sand, calendars, or coins, and let those comparisons serve as stepping stones. Each one brings us closer to appreciating the scale of our galaxy, and then the scale of the universe beyond it. Perspective doesn't shrink the cosmos, it expands our ability to experience it. And as we stretch our perspective, we stretch our sense of wonder right along with it. When we speak about the size of the Milky Way galaxy, we are entering a realm where numbers lose their normal meaning. Our galaxy is immense, a sprawling city of stars suspended in the dark ocean of space. It stretches across roughly 100,000 light-years from one end to the other. To begin to appreciate what that means, imagine light itself, the fastest thing in the universe, racing through empty space at 186,000 miles every single second. Even at that unimaginable speed, it would still take 100,000 years to travel from one edge of the Milky Way to the other. That number alone gives us a hint of just how vast our galactic home truly is. The Milky Way is not just a cluster of stars randomly scattered. It has a graceful, spiraling structure that resembles a giant pinwheel. Though if we could step outside and look at it from above, we would see it is not flat but slightly warped, like a disc that has been bent at the edges. Its spiral arms sweep outward from a dense central bulge where stars crowd together in tight orbits, swirling around a supermassive black hole that anchors the galaxy. That black hole, known as Sagittarius A, is about 4 million times the mass of our Sun. It is invisible to the eye, yet its gravitational influence keeps stars in the central region locked in orbit, creating a heart around which the entire galaxy turns. Our Milky Way contains between 200 and 400 billion stars, and possibly even more. These stars vary in size, temperature, color, and lifespan. Some are massive blue giants that burn bright and live fast, exploding in spectacular supernova after only a few million years. Others are small red dwarfs, burning so slowly that they can last for trillions of years, far longer than the current age of the universe itself. Surrounding many of these stars are planets, moons, and asteroid belts. Astronomers now believe that nearly every star in the galaxy could have planets orbiting it, which means that billions of potentially habitable worlds might exist within the Milky Way alone. Each of those worlds, in turn, could have its own stories, its own histories, and perhaps even its own forms of life. But stars and planets are not the only residents of our galaxy. The Milky Way is filled with vast clouds of gas and dust, raw material for new stars to form. These nebulae stretch for dozens or even hundreds of light years, glowing in soft hues as radiation from nearby stars excites the atoms within them. Some are stellar nurseries, where dense knots of gas collapse under their own gravity, igniting new stars that will one day light up the galaxy. Others are remnants of dying stars, shells of gas thrown outward in the final moments of stellar life. In this way, the Milky Way is a place of constant recycling, where stars are born, live out their lives, and then enrich the galaxy with the heavy elements needed to form planets, oceans, and eventually living beings like us. The structure of the Milky Way is layered. At its center lies the galactic bulge, a dense sphere of older stars. Beyond that spreads the galactic disk, a broad, flattened plain where most of the stars, planets, and gas clouds reside. This is where the spiral arms trace their arcs, wrapping around the galaxy like glowing ribbons. Our own solar system lies in one of these arms, the Orion arm, sometimes called the Orion Spur, a smaller branch between two of the galaxy's major arms, the Sagittarius and Perseus arms. Above and below the disk, the Milky Way also contains a halo, a vast, faint region filled with ancient stars, globular clusters, and dark matter that extends far beyond the visible light of the galaxy. Dark matter plays an essential role in the Milky Way's size and stability. Though we cannot see it directly, its presence is revealed through gravity. The stars in the galaxy orbit far faster than they should if only visible matter were present. This implies that the Milky Way is embedded in a massive halo of invisible material that outweighs all the stars, planets, and gas combined. Without this unseen mass, the galaxy would not hold together. Dark matter stretches beyond the luminous disk, giving the Milky Way a true diameter closer to 1 million light-years when its full extent is considered. Though the bright, starry portion we recognize is only about a tenth of that size, the galaxy is not static. It rotates, with stars in the outer regions taking hundreds of millions of years to complete a single orbit around the center. Our own solar system, moving at an average speed of about 514,000 miles per hour, takes roughly 225 million years to circle the galactic core once. That means during the entire history of human civilization, we have barely moved at all along our path around the galaxy. The Earth itself has only completed about 20 such orbits in its 4-5 billion year history. Every orbit is a galactic year, and while we measure our lives in decades, the galaxy measures time in epochs far beyond our grasp. Another dimension of the Milky Way's size lies in its population of star clusters. Some stars form together in small groups called open clusters, loosely bound collections that eventually drift apart. Others gather into ancient globular clusters, dense spheres of hundreds of thousands of stars that orbit the galaxy like satellites. These globular clusters are among the oldest structures in the Milky Way, relics from its earliest days. They orbit far out in the halo, providing astronomers with clues about how the galaxy first formed and grew. The Milky Way is also home to countless stellar remnants. White dwarfs, the cooling cores of dead stars, drift silently through space. Neutron stars, incredibly dense and only a few miles across, spin rapidly and emit powerful beams of radiation. Black holes, scattered throughout the galaxy, bend light and swallow matter, though most remain undetected. These remnants add to the complexity of the galaxy, filling it not just with shining stars, but with ghosts of stars that have long since faded. When we describe the size of the Milky Way, we are not only talking about its width or the number of stars it holds. We are describing a dynamic ecosystem, a vast interconnected system where every component influences the whole. The gas and dust feed star formation. The stars enrich the galaxy with heavier elements. The black holes and neutron stars shape their surroundings with intense gravity. And the dark matter provides the invisible skeleton that holds everything together. The Milky Way is a living structure on a cosmic scale, evolving across billions of years and continuing to change even now. To help us picture its size, astronomers often turn to analogies. If the Milky Way were shrunk down to the size of the United States, our entire solar system would be no larger than a coffee cup sitting somewhere along the plains. If it were shrunk down to the size of a dinner plate, our solar system would be smaller than a grain of salt. These comparisons highlight the immense gap between the galactic scale and the planetary scale. We might feel that the solar system itself is vast after all. Light takes more than 8 minutes just to travel from the Sun to Earth, and hours to reach the outer planets, but in the context of the galaxy, it is almost nothing at all. The size of the Milky Way also becomes more profound when we think about distance in terms of communication. If we tried to send a radio signal from one side of the galaxy to the other, traveling at the speed of light, it would not arrive for 100,000 years. Entire civilizations could rise and fall in that span. This vastness makes the possibility of communication with extraterrestrial life more complex, not because life may not exist, but because the galaxy itself is too large for us to easily bridge those distances. Even our most ambitious spacecraft, moving tens of thousands of miles per hour, would take tens of thousands of years just to leave the galactic neighborhood, despite its immensity. The Milky Way is just one galaxy among trillions. Yet for us, it is home. Every star we see in the night sky belongs to this one galaxy. Every story we tell about the cosmos, every exploration we dream of, begins within this single spiral. Its arms stretch out like vast pathways of light, and within them lie the building blocks of worlds, life, and consciousness. Understanding the size of the Milky Way is not just about memorizing numbers. It's about feeling the vastness of the place we inhabit, recognizing that our world is part of a system far beyond what we can touch, and beginning to sense the depth of the journey that lies ahead as we expand our perspective outward into the universe beyond. When we talk about our place within the Milky Way galaxy, we are talking about more than just coordinates on a cosmic map. We are talking about our position in an immense system, one so large that even the fastest spacecraft humanity has ever built has only just begun to scratch the surface of its scale. The solar system, with its planets, moons, comets, and asteroids, feels huge from our perspective here on Earth. Crossing from one planet to another is a monumental task, requiring years of travel, vast amounts of fuel, and extraordinary precision. Yet, when we step back and look at where the solar system lies in the Milky Way, it becomes almost invisible, a mere fleck of dust clinging to one spiral arm of the galaxy's vast disk. Our solar system resides in a region called the Orion Arm, sometimes referred to as the Orion Spur. This is not one of the Milky Way's major spiral arms like the Sagittarius or the Perseus arms. Instead, it is a smaller, secondary branch that sits between those larger arms, like a side street connecting two enormous cosmic highways. From our perspective, it feels like the center of everything. After all, it contains the Sun, the Earth, and every star we can see with the naked eye. But from the galaxy's perspective, the Orion Arm is just a quiet neighborhood in an endless city of stars. The Sun itself is located about 26,000 light-years from the galactic center. That means if we could travel at the speed of light, which is impossible for us right now, it would still take 26,000 years to reach the dense hub of stars and gas that cluster around the supermassive black hole at the galaxy's heart. To put that into perspective, all of recorded human history is only a few thousand years old. Civilizations have risen and fallen, empires have come and gone. But if you measured the distance to the galactic core in human history, you would need to stack thousands upon thousands of histories end to end. And even then, you would not come close to the time it would take to travel there at the speed of light. That is the scale of our position. The Sun orbits around the galactic center, dragging the entire solar system along with it. We are not stationary. We are on a journey. At a speed of about 514,000 miles per hour, the Sun completes a single orbit around the galaxy roughly once every 225 to 250 million years. This is called a galactic year. During one of these immense cycles, continents shift on Earth, species evolve and go extinct, and the entire face of our planet changes. The dinosaurs, for example, appeared about 230 million years ago, which means the Earth was in almost the same spot in its galactic orbit than as it is now. The last time Earth was in this position around the galactic center, life on this planet looked completely different. That is the timescale of our journey through the Milky Way. Our location in the Orion Arm is also significant in another way. It is a relatively calm and stable region. The spiral arms of galaxies are where star formation is most active, with massive young stars burning brightly and dying violently in supernova. These regions are spectacular but chaotic. The Orion Arm, however, is quieter. It has enough star-forming regions to make it rich in variety, but it is not so turbulent that life on planets like Earth is constantly threatened by nearby stellar explosions. This balance may be one of the reasons life has been able to thrive on Earth for billions of years. Our place in the galaxy is not just a matter of distance, it is a matter of survival. When we look up at the night sky, every star we see belongs to the Milky Way. The human eye, even under the darkest conditions, cannot see beyond our own galaxy without the help of telescopes. The stars form familiar constellations, patterns that ancient cultures used to navigate, tell stories, and mark the passage of time. But in reality, these stars are scattered across vast distances. Some relatively close to us, others much farther away. The Orion constellation, for example, includes stars at different distances, yet from our vantage point, they appear grouped together. This is another reminder of our place in the galaxy. We see it only from one angle, locked onto our small patch of the Orion Arm, and our view is shaped by that perspective. Beyond the stars, we can see with the naked eye lies an even richer field of objects revealed by telescopes. There are open clusters like the Pleiades, where stars are born together and shine as a family before drifting apart. There are nebulae like the Orion Nebula, a massive stellar nursery where new suns are igniting in the gas and dust. There are also remnants of stars that have died, such as white dwarfs, neutron stars, and black holes. All of these are scattered around us in the Orion Arm, part of the same galactic neighborhood that we call home. It's humbling to realize that our solar system is not even near the center of the galaxy. We are located in the outer regions, far from the dense hub where stars orbit close to the black hole. The central bulge of the Milky Way is crowded with stars, many of them older and redder, orbiting tightly around Sagittarius A. It is a place of extreme gravity and high energy. If we lived there, the night sky would be dazzlingly bright with countless stars. But our place in the Orion Arm is far from that brilliance. Our sky looks relatively sparse, sprinkled with a few thousand visible stars, most of them separated by light years of empty space. This isolation, however, gives us something valuable: stability. Life has had the time and the quiet conditions to grow complex on Earth. The solar system's position is also part of a much larger pattern. Our galaxy belongs to a group of galaxies known as the Local Group, which includes Andromeda, the Triangulum Galaxy, and dozens of smaller galaxies. Within this local group, the Milky Way is one of the two largest members, its mass rivaling that of Andromeda. The local group itself is part of the Virgo supercluster, which is only one region in a vast web of superclusters stretching across the universe. So, place in the Orion Arm is both humble and significant. It is humble because we are just a tiny part of a single galaxy in a sea of trillions. It is significant because this tiny part contains Earth, the only place we know so far that harbors life. There is also something poetic about our position. We are halfway between the galactic center and the edge, in a quiet arm that offers both protection and beauty. We orbit with billions of other stars, each one potentially hosting its own planets, and perhaps its own versions of life. We drift through the galaxy like a ship sailing on a vast ocean, surrounded by wonders we have only just begun to explore. Every star we see is a neighbor in our galactic community, and every photon of starlight that reaches us is a reminder of the immense neighborhood we inhabit. As we study our place in the galaxy, we begin to understand that location shapes experience. Just as living near a river or a mountain on Earth affects how human cultures grow, living in the Orion arm of the Milky Way has shaped the conditions for life on Earth. The calmness of our neighborhood, the distance from dangerous supernova, the richness of nearby star-forming regions, all these factors have contributed to the possibility of life existing here. We are not randomly placed. We are situated in a location that has allowed us to thrive, at least for now, as the galaxy continues its long cycles of change. Our place within the Milky Way is not just a set of coordinates measured in light years. It is a story. It is the story of a small solar system orbiting an average star, tucked away in a minor spiral arm of a vast galaxy. It is the story of how that quiet location created conditions where life could begin, evolve, and eventually wonder about its own existence. It is the story of how, in a universe so large and ancient, we have found ourselves not only alive but aware, able to look up at the stars and ask questions about where we are. And every time we do, the answer reminds us that we are part of something immeasurable, part of a galaxy that is both incomprehensibly vast and intimately our home. When we begin to step back from our home within the Milky Way, the scale changes again. Our galaxy, immense as it is, with its hundreds of billions of stars and sprawling spiral arms, does not exist in isolation. Just as Earth is one planet among many orbiting the Sun, the Milky Way is one galaxy among many bound together by the invisible pull of gravity. This larger neighborhood is called the local group, and it represents our next level of cosmic context. Understanding the local group is essential, because it shows us that even our vast galaxy is part of a greater system, a community of galaxies stretching across millions of light years. The local group spans about 10 million light years across and contains more than 80 known galaxies, though most of them are small dwarf galaxies, faint and irregularly shaped. At its heart are two giants, the Milky Way and the Andromeda Galaxy, also known as M31. These two massive spirals dominate the local group, together making up the bulk of its mass. They are gravitational partners, locked in a slow-motion dance that will eventually bring them together in a colossal merger billions of years from now. Between them lies the Triangulum Galaxy, or M33, the third largest member of the group, though far smaller than the other two giants. The rest of the local group is made up of smaller galaxies, many of them satellites that orbit the larger ones. These smaller companions, like the large and small Magellanic Clouds near the Milky Way, are reminders that galaxies, like stars, often gather in families. The Milky Way itself is surrounded by a retinue of satellite galaxies, most of them dwarfs. The Large Magellanic Cloud LMC and Small Magellanic Cloud ZMC are the brightest and most famous, visible from the southern hemisphere as smudges of light in the night sky. These galaxies are close enough to be distorted by the Milky Way's gravity, and streams of gas connect them to us, evidence of the ongoing interactions between galaxies. Beyond these are fainter companions like the Sagittarius Dwarf Galaxy, which is currently being torn apart and absorbed by the Milky Way. Over time, many dwarf galaxies are consumed by larger ones, their stars and gas adding to the mass of the dominant galaxy. This process is one of the ways galaxies grow, not only by forming new stars, but by absorbing their smaller neighbors. Andromeda, the Milky Way's twin in many ways, is a spiral galaxy larger than our own, stretching about 220,000 light-years across, more than twice the size of the Milky Way's visible disk. It lies roughly 2.5 million light-years away, which means that the light we see from it tonight began its journey when early human ancestors were just beginning to walk upright on Earth. Despite that distance, Andromeda is moving toward us at about 250,000 miles per hour, pulled closer by mutual gravity. In about 4 billion years, the Milky Way and Andromeda will collide, merging to form a single, even larger galaxy, often referred to as Milkometa in theoretical models. This future event highlights how dynamic the local group is. Even though on human timescales it appears frozen and unchanging, the Triangulum galaxy, though smaller than either the Milky Way or Andromeda, is still impressive. Measuring about 60,000 light-years across, it is a face-on spiral, making it an object of beauty in telescopes, with its delicate arms and active star-forming regions. Triangulum is gravitationally bound to Andromeda, and the two may have interacted in the past, with their mutual influence shaping their structures. The relationship between Milky Way, Andromeda, and Triangulum defines the central dynamics of the local group. With their gravity dominating the motions of the smaller galaxies around them, the local group itself is not a random collection. Like all galaxy groups and clusters, it is held together by the mysterious influence of dark matter. The visible galaxies are only the tip of the iceberg. Beneath them lies a vast, invisible halo of dark matter that binds the group together. Without this unseen mass, the galaxies would drift apart over cosmic time. Instead, they remain gravitationally linked, orbiting and tugging on one another in slow, elegant motions across millions of years. These motions are so slow that we cannot perceive them in a human lifetime, but over cosmic scales, the dance of galaxies is as real as the orbit of Earth around the Sun. Studying the local group gives astronomers insight into the larger universe because it is the part of the cosmos we can observe most closely. The galaxies here are near enough to study in detail, to resolve individual stars, and to map their structures. By observing the local group, scientists can test theories of galaxy formation and evolution, using these nearby systems as laboratories to understand processes that occur throughout the cosmos. The ways galaxies interact, merge, and transform are written into the history of the local group, just as rings in a tree reveal its growth. The streams of stars left behind by cannibalized dwarf galaxies, the warped disks caused by past encounters, the starburst regions ignited by collisions, all of these are signatures of a dynamic galactic ecosystem. What makes the local group particularly striking is the way it mirrors structures on every scale. Just as stars gather into galaxies, galaxies gather into groups, groups into clusters, and clusters into superclusters. The local group is our stepping stone, the next level of structure above the Milky Way itself. And from here, we can begin to glimpse the architecture of the cosmos. It is like moving from your own neighborhood to your town, and then to your state, each level showing how your home fits into something larger. Our home is not only Earth, not only the solar system, not only the Milky Way. It is the local group, a galactic family drifting together through space. And while the local group seems vast from our perspective, stretching millions of light years, it is still only a tiny pocket of the universe. Beyond it lies the Virgo supercluster, and beyond that, a cosmic web of galaxies threading across billions of light years. Yet the local group is special because it is where we belong. Every star we see, every galaxy we can study in detail, every cosmic story we tell begins here, in this modest cluster of galaxies tied together by gravity. It is our cosmic neighborhood, a place both immense and intimate, filled with giants like Andromeda, smaller companions like the Magellanic Clouds, and countless faint dwarfs that flicker like fireflies in the dark. The scale of the local group challenges our sense of distance, just as the scale of the Milky Way challenges our sense of size. Light itself takes millions of years to cross from one side of the group to the other. If a civilization in Andromeda sent a signal today, it would not arrive here until long after human history as we know it has passed into legend. And yet, despite these enormous separations, the galaxies of the local group remain connected, bound by gravity in a way that ensures their fates are tied together. In billions of years, the Milky Way and Andromeda will merge, the local group will grow denser, and the galaxies we see today will become parts of a single, larger structure. In the end, the local group is not just a collection of galaxies. It is a reminder that even at the grandest scales, the universe builds structure through relationships. Just as planets orbit stars, and stars gather into galaxies, galaxies themselves cluster into groups. Our place in the local group situates us within this grand hierarchy, giving us a sense of belonging in the endless cosmos. It is both humbling and inspiring to know that while our world is small, it is part of a galactic family, moving together across the infinite backdrop of the universe. When we look beyond the local group, we begin to see an even larger pattern emerging, one that reveals just how deeply connected our galaxy and its neighbors are to a vast web of cosmic structure. The local group, which feels enormous when considered on its own, is only a small part of something much greater, the Virgo supercluster. This colossal assembly of galaxies stretches across more than 110 million light-years and contains thousands of galaxies bound together by the invisible threads of gravity. To imagine its size, consider that a single light-year is nearly 6 trillion miles, and then multiply that by 100 million. The sheer scale is staggering, and yet even this immense structure is only one piece of an even larger cosmic web. The Virgo supercluster gets its name from the Virgo cluster, a massive concentration of galaxies near its center. The Virgo cluster is the largest and most prominent feature of the supercluster, containing over 1,300 galaxies, with some estimates reaching as high as 2,000. Many of these are elliptical galaxies, vast and featureless, while others are spirals similar to our Milky Way. The cluster itself is located about 65 million light-years away from us, and it dominates the gravitational landscape of this region of the universe. Like a city surrounded by suburbs, the Virgo cluster sits at the heart of a supercluster filled with smaller groups of galaxies, each one orbiting and drifting under the influence of the central mass. Our own local group lies on the outskirts of this supercluster. We are part of a region known as the local sheet, which includes other small groups of galaxies like the M81 group and the Centaurus A group. These groups are linked together by gravity, all flowing slowly toward the dense core of the Virgo cluster. This movement is part of what astronomers call the cosmic flow, the large-scale motion of galaxies as they are pulled by massive structures in the universe. The Milky Way is not just orbiting within itself or moving relative to Andromeda, it is also part of a larger migration, slowly drifting with thousands of other galaxies toward the heart of Virgo. The Virgo supercluster is an excellent example of the universe's large-scale architecture. Galaxies are not scattered randomly through space. Instead, they are arranged in vast filaments, sheets, and clusters that form a kind of cosmic web. These structures are shaped by gravity, the distribution of dark matter, and the expansion of the universe itself. Within this web, voids stretch like enormous empty bubbles, while clusters and superclusters form the dense intersections where galaxies gather. The Virgo supercluster is one such dense region node in this vast network. Our place within it reminds us that the Milky Way is not just a solitary island, it is a part of a much larger continent of galaxies. Joined together by unseen bonds, the supercluster contains a wide variety of galaxies, from massive giants to tiny dwarfs. The elliptical galaxies in the Virgo cluster are particularly notable because they are often the remnants of past collisions. When spiral galaxies like the Milky Way and Andromeda collide, they eventually merge into large, smooth ellipticals. These galaxies are older, filled with redder, more ancient stars, and lacking in the gas and dust needed to form new stars. By contrast, spiral galaxies are rich in gas and dust, forming stars in their sweeping arms. The Virgo supercluster is filled with both kinds, offering a snapshot of galactic evolution across billions of years. By studying it, astronomers can learn how galaxies interact, merge, and transform over time. The mass of the Virgo supercluster is staggering. It is estimated to contain more than a quadrillion times the mass of the Sun. Much of this mass, however, is not in the form of stars or planets, but in dark matter and hot gas. Dark matter forms the gravitational scaffolding that holds the supercluster together, while enormous clouds of hot gas fill the space between galaxies, heated by the gravitational forces at work. These intergalactic gases are so thin that they are almost a vacuum, yet over such vast volumes they add up to significant amounts of mass. They are detectable only through their faint X-ray emissions, which reveal the invisible environment in which galaxies drift. Our view of the Virgo supercluster has evolved over time. For much of human history, we had no concept of galaxies beyond the Milky Way. It was only in the 20th century that astronomers discovered the true nature of spiral nebulae, realizing that they were, in fact, entire galaxies far outside our own. The discovery that galaxies themselves clustered together into even larger structures came later, reshaping our understanding of the universe's scale. The Virgo supercluster became one of the first recognized superclusters, and today it remains a cornerstone in our map of the cosmos. In recent years, astronomers have redefined the Virgo supercluster as part of an even larger structure called Laniakea, meaning immense heaven in Hawaiian. Laniakea spans over 500 million light-years and contains around 100,000 galaxies. Within this larger framework, the Virgo supercluster is just one lobe, one section of a structure so vast that it defies ordinary imagination. The recognition of Laniakea highlights the fact that superclusters are not isolated. They are interconnected, flowing into one another across unimaginable distances. The galaxies within them move like rivers, drawn toward regions of greater density in what astronomers call the great attractors of the universe. Despite these larger connections, the Virgo supercluster remains our most immediate supercluster. It is the structure that contains us, our galaxy, and our neighbors. It defines the environment in which the Milky Way has lived for billions of years, and will continue to live for billions more. As we map it in greater detail, we uncover the intricate relationships between galaxies, the flows of matter, and the gravitational forces shaping the cosmos. It serves as a reminder that no galaxy exists in true isolation. Each one is part of a larger story that extends far beyond its boundaries. For us, here on Earth, the Virgo supercluster provides a framework of perspective. It reminds us that the Milky Way, vast and majestic, is still only one small thread in a tapestry far greater than itself. The distances between galaxies in the supercluster are immense, yet they are bound together as part of a common structure. This balance between separation and connection is part of the beauty of the cosmos. On one hand, galaxies are isolated islands, separated by millions of light-years of near-empty space. On the other hand, they are joined by the gravity of the supercluster, moving together as part of a larger whole. Thinking about the Virgo supercluster can bring a kind of quiet awe. When we lie beneath the night sky, it is easy to feel small, even insignificant. But when we understand that the light from those stars belongs to a galaxy that itself belongs to a supercluster of thousands of galaxies, our sense of place shifts. We are part of a structure so vast that it dwarfs even the imagination, and yet, it is also intimate, because it is our home. Just as we belong to a city, a state, a country, and a planet, we also belong to the Milky Way, the local group, and the Virgo supercluster. Each layer expands our sense of belonging outward, from the personal to the cosmic, until we see ourselves not as isolated beings, but as participants in a universe of endless scale. The Virgo supercluster, in all its immensity, is still only one supercluster among many. Beyond it lies the Centaurus supercluster, the Hydra supercluster, and countless others. Together, they weave the vast fabric of the universe, stretching across billions of light-years. But for us, Virgo is the first step into this larger cosmic web. It is the nearest large-scale structure that reminds us that even galaxies are part of something greater. It connects us not just to Andromeda, not just to the local group, but to thousands of other galaxies scattered across the sky, each one a universe of stars in its own right, all bound together in the immense heaven of the cosmos. When we step beyond the Virgo supercluster, our vision of the cosmos expands once again. This time to the largest scale we can meaningfully measure, the observable universe. The very phrase carries weight, because it acknowledges a boundary not of the universe itself, but of what we are able to see and study. The observable universe refers to the region of space from which light has had time to reach us since the beginning of cosmic expansion. It is not the whole universe, because there may be regions beyond our horizon that we can never access. But it is vast beyond comprehension, stretching across an estimated 93 billion light-years in diameter, filled with galaxies, clusters, filaments, and voids that weave together the greatest tapestry ever known. The concept of an observable universe arises because of the finite speed of light. Light travels at about 186,000 miles per second, and while that is unimaginably fast by human standards, the universe is unimaginably old. It has been around for roughly 13.8 billion years. That means that in theory, the farthest light we could see would be from 13.8 billion light-years away. However, because the universe is expanding, the regions from which that light was emitted have moved far away during the time the light was traveling. The result is that the edge of the observable universe is not 13.8 billion light-years away, but closer to 46.5 billion light-years in every direction. When you double that distance, you get the 93 billion light-year diameter. That number does not describe the whole cosmos, only the visible bubble centered on us, created by the speed of light and the age of cosmic history. Every observer anywhere in the universe would have their own observable bubble, centered on them, a kind of cosmic horizon beyond which they cannot see. Within this observable universe are an estimated 2 trillion galaxies. Each galaxy contains billions, sometimes trillions, of stars. The Milky Way alone contains around 200 to 400 billion stars, but in the grand cosmic census, it is just one entry among trillions. Galaxies themselves come in many shapes and sizes: spiral, elliptical, irregular, each one a collection of stellar systems orbiting a shared gravitational center. Between these galaxies lies an even greater volume of emptiness, punctuated by filaments of dark matter and gas that form a cosmic web. The universe is not evenly filled with matter. Instead, it has a texture with dense regions where galaxies gather and vast voids where little exists at all. This distribution was seeded in the earliest moments of the universe, when tiny fluctuations in the density of matter grew over billions of years into the vast structures we now observe. The observable universe also contains the cosmic microwave background radiation, a faint glow that permeates all of space. This radiation is the afterglow of the Big Bang, released about 380,000 years after the universe began, when atoms first formed and light was able to travel freely. When we observe the cosmic microwave background, we are looking as far back in time as possible, to the very edge of the observable universe in terms of its earliest light. It provides us with a snapshot of the universe when it was only a fraction of its current age, and it serves as the foundation for our understanding of cosmology. The patterns in this radiation, slight variations in temperature and density, explain how galaxies and superclusters later formed. The scale of the observable universe is difficult to hold in the human mind. A light year itself is already a nearly unimaginable distance, 6 trillion miles. Multiply that by billions, and then by tens of billions more, and you begin to approach the true size. If the Milky Way were the size of a quarter, the observable universe would be larger than North America. Another way to think of it is that if you could somehow travel at the speed of light, it would take you 46 billion years just to cross from one side of the observable universe to the other. And that is assuming the universe were not still expanding beneath your feet as you traveled. The sheer magnitude stretches language to its limits, forcing us to rely on metaphors, comparisons, and imagination to even begin to comprehend it. Astronomers use a variety of tools to study the observable universe. Telescopes like Hubble and the more recent James Webb Space Telescope allow us to peer deeper into space than ever before, capturing light that has traveled billions of years to reach us. By looking farther away, we are also looking farther back in time, since the light shows us how galaxies looked when they were younger. In this way, the observable universe is not just a static image but a time machine, allowing us to witness the birth and growth of cosmic structures. Surveys like the Sloan Digital Sky Survey and projects mapping the cosmic microwave background, reveal not only where galaxies are but also how they cluster and form large-scale structures across space. One of the most remarkable discoveries of the last century is that the universe is not static but expanding. Galaxies are receding from one another, carried by the stretching of space itself. The farther away a galaxy is, the faster it appears to be moving away, a relationship described by Hubble's law. This expansion is not slowing down but accelerating, driven by a mysterious force called dark energy. Dark energy makes up about 68% of the total energy content of the observable universe, and yet we do not know what it truly is. Its presence ensures that the universe will continue to expand indefinitely, stretching the observable boundary ever farther. Even as galaxies on the most distant edges slip beyond our horizon and become forever inaccessible to our observations, the contents of the observable universe also reveal a striking composition. Ordinary matter, the kind that makes up stars, planets, and people, accounts for only about 5% of the total. Dark matter, an invisible form of matter that exerts gravitational influence but does not emit or absorb light, makes up about 27%. The rest is dark energy, driving the accelerated expansion. This means that most of the universe we can observe is not like the matter we know. It is dominated by mysterious substances we have not yet directly detected, yet their presence is undeniable, inferred from the way galaxies move, the way light bends around massive clusters, and the way the universe's expansion accelerates. In the observable universe, galaxies are arranged into an immense cosmic web. At the intersections of this web are galaxy clusters and superclusters, tied together by gravity. Between them are great voids, sometimes hundreds of millions of light-years across, nearly empty of galaxies. The pattern resembles a three-dimensional spiderweb or a vast network of filaments. This structure, which emerged from the earliest fluctuations in the cosmic microwave background, is one of the most striking features of the cosmos. It demonstrates that the universe has order even on its largest scales, a rhythm and architecture written into the very fabric of existence. The observable universe is both a frontier and a limit. It represents the farthest we can see, but not necessarily the farthest that exists. Beyond our cosmic horizon, there may be endless space, more galaxies, more clusters, more superclusters, perhaps even infinite repetition. Some cosmological theories suggest that the universe is far larger than what we can observe, possibly infinite in extent. Others imagine that what lies beyond may include regions with different physical laws, different arrangements of matter, perhaps even different constants of nature. These questions remain open, because no light from beyond the observable boundary has had time to reach us, and perhaps never will. Despite the enormity of the observable universe, it is deeply personal. It contains everything we have ever known or experienced, from the nearest star to the farthest galaxy, from the earth beneath our feet to the edge of cosmic history. It holds the cradle of life, the history of stars, the memory of the Big Bang itself. And while its size can make us feel small, it can also offer comfort. We are not adrift in nothingness, but part of a vast and intricate whole, connected to galaxies billions of light-years away by the same laws of physics, the same forces of nature, the same cosmic origin. To contemplate the observable universe is to stand on the shore of an ocean without end, knowing that every wave, every current, every horizon is part of the same boundless expanse. When we try to compare the Milky Way galaxy to the entire observable universe, we are stepping into the realm of scale so extreme that words and even imagination struggle to keep up. The Milky Way is vast by any measure. It is a barred spiral galaxy with a diameter of about 100,000 light-years, which means that even if you could travel at the speed of light, it would take you 100,000 years just to cross from one edge to the other. Within its spiral arms and dense central bulge lie an estimated 200 to 400 billion stars, each one potentially surrounded by its own system of planets, moons, and asteroids. The Milky Way is also home to enormous clouds of gas and dust, nebulae where new stars are born, and dark matter that provides the invisible framework binding it together. To the human mind, the galaxy is overwhelming in its immensity, filled with wonders beyond counting. Yet when placed next to the universe, it becomes only a faint flicker in a sea of countless lights. The first way to grasp the comparison is to consider the numbers. Our Milky Way is one galaxy among roughly 2 trillion in the observable universe. That means for every star in the Milky Way, there may be hundreds or thousands of other stars scattered across other galaxies. If the Milky Way were a single grain of sand, the observable universe would be like an endless beach stretching farther than the eye could see. The scale is so extreme that even metaphors strain to carry the meaning. A grain of sand compared to a continent may sound small, but it still does not come close to how minuscule the Milky Way is within the whole of existence. The observable universe is not just larger than the Milky Way, it is incomprehensibly larger, so much so that our galaxy does not stand out any more than a single leaf in a vast forest. Another way to think of the comparison is in terms of structure. The Milky Way has spiral arms that sweep gracefully around its central bulge, with stars, gas, and dust orbiting a supermassive black hole called Sagittarius A. The galaxy is dynamic, rotating once every 225 to 250 million years, carrying the Sun and its planets along in a slow orbit around the center. Yet the universe, in its grand design, contains galaxies not as isolated objects but as part of an immense network. The Milky Way belongs to the local group, which itself is part of the Virgo supercluster, and that supercluster is only a branch within the even larger structure called Laniakea. All of these structures are, in turn, part of the observable universe. The Milky Way's role in this larger network is significant to us, but on the cosmic scale, it is only one tiny thread in a nearly infinite web. When astronomers map the universe, they see patterns emerging at scales far beyond the dimensions of a single galaxy. Galaxies cluster together, forming groups and superclusters which then link into filaments and walls that span billions of light years. Between these filaments lie vast cosmic voids, regions almost entirely empty of galaxies. The universe at this scale resembles a three-dimensional web or sponge, with dense knots and long strands of matter separated by enormous empty spaces. In this picture, the Milky Way is one small point, one node among trillions, its light shining faintly amid the broader architecture of the cosmos. The difference between a galaxy and the universe is not just size, it is also complexity. With the universe revealing a structure so vast and interconnected that the human mind can scarcely process it, the comparison can also be drawn in terms of time. The Milky Way is about 13.6 billion years old, nearly as old as the universe itself, which is 13.8 billion years old. Our galaxy has been here for almost the entire cosmic history, forming not long after the first stars lit up the darkness. Yet the universe encompasses not just one history, but countless ones, with galaxies forming, colliding, and evolving in every corner of the observable horizon. The life of the Milky Way is impressive, but it is only a single story within a library of 2 trillion others. Each galaxy has its own timeline, its own evolution, its own past and future. Comparing the Milky Way to the universe is like comparing a single page to the entire library, not meaningless, but tiny in proportion. Scale can also be measured in terms of potential. The Milky Way may contain hundreds of billions of stars and perhaps billions of planets capable of hosting life. Yet when you expand this number across the entire universe, the possibilities multiply beyond imagination. If the Milky Way is a cosmic city filled with lights, the universe is a vast network of megacities stretching in every direction. Even if only a small fraction of galaxies contain habitable planets, the sheer number of galaxies makes the potential for diversity and wonder nearly infinite. The comparison reminds us that while our galaxy feels enormous, it is only a fraction of the opportunities and mysteries contained within the observable cosmos. Another striking way to think about the comparison is to imagine the night sky. Every star we see with our eyes belongs to the Milky Way. When you look up at Orion, or the Big Dipper, or the bright band of the Milky Way itself. You are looking at stars in our own galaxy, and yet, beyond them, far fainter and harder to detect, lie other galaxies. The Andromeda Galaxy, visible as a faint blur to the naked eye on dark nights, is the nearest large galaxy to us, about 2.5 million light-years away. It is only the closest neighbor, yet already its scale dwarfs human imagination. Multiply Andromeda by trillions, scatter them across billions of light-years, and you begin to approximate the true immensity of the universe. The Milky Way is like a familiar neighborhood, while the universe is an entire planet, filled with neighborhoods we will never visit. The comparison also highlights how small our solar system is even within the Milky Way. The solar system orbits in one of the galaxy's spiral arms, the Orion arm, about 27,000 light-years from the center. To us, the solar system feels enormous, containing 8 planets, dozens of moons, asteroids, comets, and the Kuiper belt stretching into interstellar space. But in galactic terms, it is a tiny dot. And when we compare the Milky Way to the universe, our solar system shrinks further still, becoming invisible against the backdrop of trillions of galaxies. The human scale vanishes into insignificance, first against the galaxy, and then against the observable universe. Yet, in that insignificance lies perspective, the realization that the universe does not revolve around us, but embraces us as part of its grand totality. Even so, the comparison should not inspire despair, but awe. To know that the Milky Way is so small compared to the universe is to know that we live in a cosmos beyond comprehension, a cosmos full of beauty, mystery, and possibility. Our galaxy may be one among trillions, but it is our galaxy. It is the place where stars gave birth to the elements of our bodies, where the sun formed, where Earth came into being, where life arose. While the universe contains more, the Milky Way contains us, and in that sense, it is precious beyond measure. Comparing the galaxy to the universe does not diminish it, but frames it within a larger story. One in which every galaxy, no matter how small, has its role to play. The Milky Way compared to the observable universe is like a single heartbeat compared to the lifetime of the cosmos. Each is part of something larger, each necessary for the whole, and each filled with meaning when placed in context. The observable universe overwhelms the imagination, but the Milky Way anchors us within it, giving us a home from which to gaze outward. To compare them is to understand both the immensity of the universe and the significance of our galaxy within it. When we take a step back from the numbers, the measurements, and the calculations of cosmic scale, what remains is the emotional and philosophical weight of knowing just how vast the universe truly is compared to our galaxy. Facts and figures can tell us that the Milky Way is 100,000 light-years across, that the observable universe stretches some 93 billion light-years, and that there are trillions of galaxies beyond our own. But beyond the science, there is a profound sense of human connection to the cosmos, and with it, the chance for deep reflection on who we are, where we belong, and how we find meaning under skies that stretch into eternity. For most of human history, the night sky was not understood in terms of galaxies and cosmic structures. It was a canopy of lights, mysterious and beautiful, inspiring myths, legends, and stories across every culture. The stars were seen as gods, ancestors, spirits, or guides, depending on the people who gazed at them. The Milky Way itself was often described as a river of light, a bridge to the heavens, or a road traveled by souls. These interpretations were poetic attempts to understand something that felt infinitely greater than daily life. And even today, with telescopes and satellites mapping every corner of the sky, that feeling of awe remains. The difference now is that we can connect that awe to knowledge, grounding wonder in scientific truth without losing its beauty. When we realize that our entire galaxy is just one of trillions, the first reaction might be a sense of smallness. Compared to the observable universe, the Milky Way is no more significant than a drop of water in the ocean. Our solar system, which feels so vast when measured in light hours or light days, becomes invisible against the canvas of the galaxy. Earth, in turn, is a tiny pebble circling a single star, and each of us is a fragile being clinging to a narrow band of life on that pebble's surface. This perspective can be humbling, even unsettling, because it challenges the human instinct to place ourselves at the center of everything. But there is another way to interpret this cosmic humility. To be small is not to be meaningless. The atoms that make up our bodies were forged in the hearts of stars, scattered by supernova, and gathered together by gravity billions of years ago. The iron in our blood, the calcium in our bones, the oxygen we breathe, all of it is cosmic origins. In that sense, we are not separate from the Milky Way or the universe. We are the universe becoming aware of itself. Our existence is proof that out of the immense scale of galaxies and stars, consciousness can emerge. It may be rare, or it may be common, but either way, it is extraordinary. The reflection that follows is not about feeling lost in the universe, but about recognizing our deep and unbreakable connection to it. There is also a unifying aspect to this perspective. Every human being on Earth, no matter their nation, culture, or history, shares the same sky. When we compare the Milky Way to the universe, we do not only discover how small we are, we discover how boundless existence is. The galaxy gives us a home. The universe gives us a context, and together, they give us perspective. The human connection to this vastness is not in trying to measure up to it, but in realizing that we are woven into it. Our breath, our heartbeat, our lives are all connected to stars, galaxies, and cosmic structures billions of light years away. Reflection on that fact is not about diminishing ourselves, but about expanding our sense of belonging. Until it stretches as wide as the sky itself, the comparison between our Milky Way galaxy and the vast expanse of the universe is more than just a scientific exploration of scale. It is a journey into perspective, meaning, and connection. The Milky Way, with its billions of stars, planets, and mysteries, already feels incomprehensibly large, yet it becomes only a faint brushstroke when set against the canvas of the observable universe. Trillions of galaxies stretch across a cosmos so immense that no single lifetime, no single civilization, could ever hope to grasp it all. And yet, within this immensity, we find not despair, but inspiration. We learn humility by recognizing our smallness. But we also discover significance in knowing that the atoms of our bodies were born in ancient stars, that we are not apart from the universe, but expressions of it. The vastness of the cosmos reminds us that our divisions and conflicts are fleeting, while our shared existence as travelers on this pale blue dot is profound. Science gives us the tools to measure distances and ages, but reflection gives us the wisdom to see unity, gratitude, and wonder in the night sky. Ultimately, comparing the Milky Way to the universe is not only about size, it is about perspective. It is about understanding that we are a part of something infinitely greater, something that stretches beyond imagination, and yet something that flows through us as much as around us. The galaxy gives us a home. The universe gives us a context. And together, they give us a reminder that while we are small, we are also extraordinary fragile beings with the rare gift of being able to look up, to wonder, and to know that we belong to the stars.